air. Okay, and that is actually the atmosphere. We'll see what the blanket, also known as the envelope or the blanket of the earth. Okay, just 1 minute before I think Ayush is going to join. So I was discussing the environment. The atmosphere is what? It is the blanket of the air which is present, or the envelope of air which surrounds the atmosphere, the earth. That is known as the atmosphere. Now, why I'm telling you this is because it has a lot of air particles. It has a different set of air particles, and that affects the people on earth, and that affects the performance of aircrafts. It is only one reason why, because of air density. Now, if you see the picture on the right side, that clearly tells you what is air density. The amount of air particles at the station or at wherever you are standing. Right now, I'm sitting at my home. I'm in front of laptop. All the air particles are present in the oxygen and all. I'm able to breathe in. Whatever I'm breathing in and all, those compose the air, and that is the density of particles, or known as thickness of the air. This thickness of the density is really important throughout the lectures, and it is represented by rho. Okay, it is represented by rho. So in the direction of the low pressure, you should always remember these points. We have something known as PGF, or pressure gradient force. What's it this? Basically, all the airflow in all our surrounding goes from high pressure area to low pressure area. Imagine that these particles are bouncing really fast. Okay, in a room you stuffed a lot of particles. When you stuff a lot of particles inside a room, they want to escape out. When they want to escape out, they are going to a region of low pressure. So always goes, that is known as pressure gradient force. That's a part of meteorology again. So what is important to technical general is static pressure. Now there are two types of pressure in the atmosphere. Okay, two types of pressure. One is static. The second is a dynamic. I'll just write it here, dynamic. We'll discuss dynamic later in this class only. The first type is static. Now, static pressure is simply, as I told you, air particles are present all around, right? They're sitting over top, they're sitting over my laptop, they're sitting at your place. These particles have some weight because they have some mass. That mass, when they are put on your body, there is a pressure that is known as static pressure. So you can see all these particles lining up on you, और ये सारे particles आपके ऊपर यहाँ आ रहे हैं, और this is known as static pressure. This is when the object is stationary. This is when the object is stationary. So as I told you, the static pressure is the result of the weight of the atmosphere pressing down the air beneath. जो भी ऊपर हमारे है air particles, pressure push कर रहे. Now you have to understand this. Let's say Satya is standing here and Sonak is standing here. ठीक है, इन दोनों में से किसके ऊपर स्टैटिक प्रेशर ज्यादा होगा? Who will have more static pressure? सोनक और सत्या?
So the one who is close to the earth, closest to the earth.
Right. Satya will have more static pressure in this case. Okay, because the air particles here are more, and that is the basics of static pressure. You have to understand. The lower the altitude, the greater the force. Okay, the unit remains standard. Pressure is equal to force upon area. Okay, force is what? Force is represented by Newton, and area is meter square. So this is the unit of static pressure as well. It is denoted by small p or papa. Okay, p is for papa. Now, yeah, in aviation, remember that we always use hectopascals. 1 hectopascal is equal to 100 pascal. Now, what is pascal? Pascal is the SI unit of pressure. Okay, so 1 hectopascal is equal to 100 hectopascal. Always remember this. I'll be asking you later in this lecture. Also, we need to consider the fact that in our atmosphere, temperature and density vary. India में आज गर्मी है. Russia will have सर्दी. Everywhere in the atmosphere, there is different weather conditions. So in aviation, we use something known as degree Kelvin. Okay, you must have heard of centigrade or Celsius or Fahrenheit. These things you've already heard. But in aviation, we'll be using Kelvin. Throughout this technical general, you'll be only studying with terms of Kelvin. Simple unit of conversion of Kelvin is that if you have 0 degrees Celsius, that will equal to 273 Kelvin. Let's take an example. Suppose 15 degrees Celsius. Yeah, someone wants to ask something?
Sir, good afternoon.
Oh, Ayush, finally, you made it. Okay.
Sorry, sir.
No problem at all, no problem. So I am recording this lecture, no worries, okay? We just started it. I'm just explaining the basics, okay? So if you want to convert the 15 degree Kelvin into 15 degree Celsius into Kelvin, how are you supposed to do? Simply add
273 plus 50.
Perfect. Whoever said that, good. Okay. So it becomes 288 Kelvin. That becomes your answer. Anyways, this is just the basics. You already know this. The air density, as I told you in the first
So I
slide.
have a doubt.
Yeah, go ahead.
So like in aviation sector, like when we are flying, sir, discussion regarding Kelvin or Celsius.
I'll answer you. So we will follow Kelvin when we're using the instruments. That is engineer perspective. And whenever we are flying, we'll use degree Celsius because we follow who? We follow UK. UK follows Kelvin. And if you talk about USA, they follow Fahrenheit. Okay, these are the UK. So India follows UK, so India will follow this. That is, we'll always go for outside air temperature 10 degrees Celsius, 12 degrees Celsius. Whereas engineer's perspective, we will see the instruments, they work on the Kelvin. Okay. Alright. So the air density is measured in the rho. Formula for air density is what? Mass upon volume. That is the unit. kg per meter cube. Now we need to understand density and what is the result on a temperature or different atmosphere. If my static pressure reduces, density reduces. That's what we saw in the example. Okay, static pressure reduces, density reduces. If my temperature increases, the density reduces. Why? If you see, if I have, let's say, a pan, okay, and I boil this pan. Pan has some water, so I'm boiling this water. What will happen is, when I boil this water, all these particles will start to vibrate. When they start to vibrate, they want others to go outside. When they go outside, our density reduces. And because we increase the temperature, that is the reason density reduced. So always remember this example. Then we have humidity. Now what is humidity? Humidity is the presence of water vapor. Okay? Water vapor, if some water particles are present in the atmosphere, that means that it is humid. So if I take an example of a box, okay, and I put air particles, let's say oxygen is present inside, 1, 2, 3, 4. Now I include some water vapor. I add some water vapor into it. Okay, water vapor. So what will the water vapor do? They will they will just put those oxygen particles out. So overall, the air particles or the number of air particles reduced. That makes it less dense, or that makes the density reduced. So the more the humidity, that means the more the number of water particles, the less space for air particles, and hence lesser the density. Alright, this is how DGCA wants to trick you. They will say that the more number of particles are present in the air, okay, or humidity भी ज़्यादा है, then what will happen to density? You will think that the density will increase, but this is the rationale. Anyways, now we go back to class 8th and we'll discuss ideal gas law. You must have remembered something like this. PV is equal to nRT. Now instead of n, we will replace the n from rho. No problem, you don't remember it. I'll make you remember it. Okay. You remember Boyle's law, Charles' law. When you put together all these laws, we get something known as ideal gas law, in which basically it is pressure into volume is equal to density into rho. Okay. R is the constant. T is your temperature. So if you put together, this becomes your equation. Why I'm including this equation? Because this equation will tell the same thing, which I derived the results. If you see, if I increase my temperature, okay, what is happening to the volume? Or what is happening to the density?
Sir,
yeah?
Sir, if the temperature is increasing, the density, the pressure is not increasing.
Yeah, pressure is increasing. What about the density?
The density reducing.
Perfect. So we can see from this also, if I erase all this, okay, if I write here, can I write temperature is inversely proportional to density from this formula?
Yes, sir.
Exactly, that's what my point is. So the things which we derived are present with this formula. So if you forget the things which I taught you, you can always go back to this formula. Now tell me, I have a beautiful story. Okay, today we all are going to Mount Everest. If you go to the Mount Everest, okay, you are climbing up, so the altitude is increasing. What happens with the altitude? Does the density reduce or increase?
So reduce.
Is everyone on board? Density will reduce. Tell me, if the density reduces, why doesn't the temperature increase? Density is reducing, temperature should increase. So why don't we wear shorts while climbing the Mount Everest instead of those high jackets?
So is it because of lapse rate? Like as we go higher, temperature reduces.
So why is the lapse rate present if the density is reducing?
The pressure is also decreasing.
Yeah.
So
pressure.
there are less particles to conduct the heat. The particles are
That is
like there
partially.
should be more particles.
That is partially correct. Who said who said pressure? Someone said pressure also, no?
So means
Ayush, right? Pressure. So why, if the pressure is reduced, temperature will reduce?
sir, because the molecules, as the pressure would be decreasing, so the molecules will have a larger area than it means the molecules which are air molecules cannot produce the heat by striking to each other. That's why the heat is decreasing. As if the pressure is decreasing, the heat is also decreasing.
Okay. Yes. From the formula, you can derive one more result. What is that? Pressure is directly proportional to temperature. So, as we discussed, static pressure reduces as we go up, so the temperature will also reduce. So I think it's a middle road. Okay, why? Because both of them are indicating a different result. But you need to understand one thing very very carefully, that when we go up, that is जब हम ऊपर जाते हैं, the static pressure reduces very very dominantly or very very drastically. So if I'm going up, let's say P, which is my static pressure, reduces 2 times than my density. So if my pressure is reducing 2 times, that means the temperature overall will start to reduce. And that is the answer that the DGCA are looking for. Okay, the static pressure is dominant. The density decreases with increasing altitude because of decreasing static pressure. However, with increasing altitude, temperature also decreases, which would tend to increase the density. But the effect of decreasing the static pressure is dominant. Static pressure इतना ज़्यादा गिर जाता है ऊपर जाते समय that the temperature has to reduce. Density cannot do anything to increase it. Okay, so that is the answer. Anyone has any doubts in this? Center of gravity, हाँ, उस पे डिफेक्ट करेगा, प्रेशर पे. हाँ सर, करेक्ट. ठीक है. Now we'll come to something very very useful in your whole life right now or in your journey throughout the pilot, known as ISA, International Standard Atmosphere. Now we'll make another story out of it. What is the story this time? Ayush is in India, in let's say Orissa. Okay, let's say Orissa. Okay. Now what is he doing? He is manufacturing an aircraft. I am in Russia. Okay, Russia. I don't know where Russia is. So Ayush is here, and I am in Russia. Let's say Kartik. Okay, what I'm doing is I'm placing an order for an aircraft. I ask Ayush, make an aircraft for me. He says, ho jayega, he will make it. What happens is he designs an aircraft according to the temperature. What is the temperature in Odisha? Let's say plus 20 degrees Celsius normally. Okay, density is also normal. So we'll just take in temperature example. But when he brings the aircraft to Russia, जब delivery हुआ and I started flying the aircraft, what happened to me? The temperature outside is 0 degrees Celsius. My aircraft instruments did not work. My aircraft performance was bad. Everything did not happen as planned. So a lot many scientists came around all the world. All over the globe, people came together and decided they will make something common. एक standard atmosphere बनाएंगे, उसका नाम रखेंगे International Standard Atmosphere. So they came up with something known as ISA, and they made sure that जहाँ भी aircraft manufacture हो रहा है, वो ये ISA table follow करेगा instruments के लिए and the design and testing or the performance. So In simple words, as I told you, the International Standard Atmosphere was created so that the calibration of pressure instruments or our instruments in the aircraft, as well as the performance, the design and testing of the aircraft remains standard throughout the globe. And the values which the ISA is depicted, it is given by the ICAO. ICAO stands for International Civil Aviation Organization. Just like DGCA is for India, ICAO is for the world. Okay. Now ICAO made sure that everyone follows this table. This is starting from one point. First point is air should be dry. Now what do you mean by air should be dry? If you have studied meteorology, you might know that there are two types of air conditions, right? One is normal,
Yes.
One is normal, which is present right now. Second is something known as saturated. Okay, I'll not go into depth, but air is dry. Then we have temperature is 15 degrees Celsius. These are perfectly ISA. Okay, we'll be doing a lot of questions on this, so please remember this. At mean sea level, we have temperature plus 15 degrees Celsius. Does anyone have a doubt in MSL or mean sea level? Do you want me to explain that?
Sure, sir.
You want me to explain? Okay. Now understand this also, okay? That right now in Mumbai, there is a lot of, okay, what is sea level? So this is my area where I'm living. These are my buildings and all. So you know that below our ground, there is a lot of water. Alright? That is my sea level. What happens is the places which are near to the coast, they will have a approximate sea level values. That is the level or the altitude is same. But places which are above, like on a mountain or something, okay, let's say the mountain or what, so the sea level will be way below. Okay, so what is the mean sea level of a place? Because of many reasons like rainfall, high tide, low tides, there are a lot of reasons जिससे कि जो level of the sea keeps on rising and dropping. Okay, it must be. So for an average, we took an average for individual airports or individual places where we require this, and we made an MSL, that is the mean of all these values. That is known as MSL for that area. MSL is not including in the International Standard Atmosphere. MSL is for individual cities or individual airports. Okay? Individual places. Simple. So MSL की वजह से at MSL, for every place at MSL, the temperature should be plus 15 degrees Celsius over 288 degree Kelvin. Again, pressure at MSL should be 1013.25 hectopascals. If you remember hectopascal, it is 100 pascals. Density should be 1225 grams per meter cube. These are all values you need to remember. Okay. Lapse rate. Now comes the lapse rate. Someone had told me lapse rate. Lapse rate is 6.5 degrees Celsius per kilometer. In simple terms, we just understood that if we climb Mount Everest, अगर हमें Mount Everest पहाड़ चढ़ना है, altitude keeps on increasing as we go up. Temperature reduced, but by how much? So ISA also made sure that is also derived. Every 1,000 feet I climb, my temperature reduces approximately 2 degrees Celsius. Okay? Let's do a small question. Let's say we are on MSN, okay, and I climb till 10,000 feet. Can someone tell me what will be the temperature according to ISA? मैं MSL में था, I climbed to 10,000 feet. Yeah, who's going to tell me the temperature?
So 5 degrees.
Yes, 5 degrees.
Okay, someone said 5 degree. Is everyone agreeing?
Yes.
Okay.
Yes, sir.
So everyone's got the answer. I'll just quickly go through if someone missed it. 15 degrees Celsius here, okay, and 10,000, 10 into 2 degree. So minus 20 degrees Celsius, okay, minus 20. Now that I've got per 1,000 feet 2 degrees Celsius minus 20 degrees Celsius. So minus 20 plus 5. So it is minus 5 degrees Celsius. So how did you get 5 degrees Celsius?
Sorry, sir. By mistake, I just forgot to tell you the minus. I missed it minus sign.
Okay, no problem. So people who are getting confused, I'll try to solve it again for you. See, at MSL, I just told you, according to ISA, the temperature should be 15 degrees Celsius. Okay. Now, as we are going 10,000 feet up, what will happen to me? per 1000 feet, that means 10,000 divided by 1000 into 2. I get what? 20 degrees Celsius. This value has to be subtracted. So 15 minus 20 gives me what? Minus 5. This is my answer. Alright, no problem. We'll be doing such questions and all. Let's move forward. That is the simple reason that temperature keeps on decreasing as we climb. But there is a limit. There is a limit to what it will reduce. The limit is minus 56.5. इससे कम टेम्परेचर ट्रोपोस्फेयर में नहीं होता. In our troposphere, minus 56.5 degrees Celsius is the least the temperature can go, and at a height of 36,090 feet. If you go and calculate with a calculator also, at this height you will get this value, and after this it becomes constant. ना increase होगा ना reduce होगा. ठीक है? From 11 to 20 kilometers. इसके बाद कुछ आता है known as stratosphere. If you have studied met and navigation also, something comes stratosphere. Now, who will tell me why the temperature increases in the stratosphere when you climb?
Sir, due to solar activities.
Okay. Solar activity. Anything specific?
The presence of ultraviolet, the ozone layer.
Perfect. That was what I was looking for. Ozone layer. Because ozone layer is present in the stratosphere, it absorbs all the UV rays, all the solar radiations, and that is why it heats up. इसीलिए वो गर्म हो जाता है, and that gives it a negative lapse rate. What is a negative lapse rate? Instead,
it's a rise in temperature on getting into higher altitude.
Correct. Negative lapse rate क्या होगा? Lapse rate का उल्टा. तो अगर altitude के साथ lapse rate क्या होता था? Temperature starts to reduce. तो negative क्या होगा? It will start to increase. So it is known as inverse lapse rate, and the value is 1 degree Celsius per 1 kilometer 1000 meters. This is the value in stratosphere. It will not be asked to you in the exams, but I am just giving you a gist what is happening in the atmosphere. Acceleration, already someone has told me, acceleration due to gravity is 9.8 Newton per meter square. Finally, I already told you this. Practically, we use lapse rate 2 degrees Celsius per 1000 feet for calculations. So this is the international standard atmosphere. Okay, I hope you know this. Any questions up till now?
No, sir.
Perfect. Okay, you can see this table also. We have this table here. Okay, when we have this table here, you can see at 0 feet, this is MSL. At 0 feet, pressure is in inches of mercury. Okay, this is inches of mercury, or you can also say 1013.25 hectopascals. That's the same thing. The same thing. Temperature 15 degrees Celsius, you can convert that into Fahrenheit and you'll get the answer. All in all, I want to summarize. With increase in altitude, my temperature will reduce with this. This is known as lapse rate. My density will also reduce. My humidity will also reduce. My pressure is also reducing. And the reduction in pressure is how much? Initially, it is 1 hectopascal per 27 feet. That means that if I climb 270 feet, my pressure drops by 10 hectopascal. Okay, so at MSL it was 1013.25 hectopascal. At 270 feet, it will become 100325 hectopascal. चलो, अब तक सब कुछ क्लियर है? वेरी गुड. ठीक है, अभी सब कुछ नॉर्मल है. अभी हम समझ चुके हैं व्हाट इज द प्रेशर, व्हाट इज डेंसिटी, व्हाट इज आवर ISA. नाउ कम्स द इंटरेस्टिंग पार्ट. अब हम इंट्रोड्यूस करेंगे एयरक्राफ्ट को. ठीक है, बिकॉज है तो टॉपिक एयरक्राफ्ट का ही ना, टेक्निकल जनरल. Dynamic pressure, as I told you in the first slide, there are two types of pressure, static and dynamic. This is the second type. Now, I've given the example many times. This I'll give you again. Remember that if you are riding on a cycle or a scooter, any two-wheeler, you face a lot of wind particles on your face when you're driving fast. That is because the air particles have something known as kinetic energy when the velocity is maintained. मतलब जब आप चल रहे होते हो, when the object is moving, relatively air particles are hitting you. Okay, this is known as kinetic energy, and in aerodynamics or in our technical genre, we'll call this dynamic pressure. Dynamic pressure is proportional to the density of the air and square of the speed of air. What is this? If I write the formula of dynamic pressure here, it will simply become directly proportional. Dynamic pressure is directly proportional to density and velocity square. Okay. Remember, static pressure is always present, but dynamic pressure is only present when the object is moving. So tell me, the red arrows here indicate water, and the blue ones indicate water.
So red one indicates static, and blue one is dynamic.
Okay, very good. Who said that? Good. The static pressure is already, dynamic pressure is given by blue arrow. Now, interestingly, one thing you might see here, static pressure is not just present from top, it is present on bottom also, from all the sides of the aircraft, even in the front. This will be helpful to you in the front also. Okay. Okay. So as
a front में मतलब तो वो dynamic हो जाएगा.
हाँ, but जैसे मैं बोल रहा हूँ, static pressure हर जगह है, ठीक है? तो एक दो पार्टिकल ऐसे भी होंगे जो स्टैटिकली प्रेजेंट होंगे उसके नोज पे एयरक्राफ्ट के, तो वो अभी मैं आपको डिस्कस करूंगा व्हाई आई एम टेलिंग यू दिस. ओके, सो आई विल जस्ट गिव यू द फॉर्मूला. ओके, ये काइनेटिक एनर्जी का फॉर्मूला था, सेम इसी का फॉर्मूला डायनामिक प्रेशर का भी है, हाफ रो वी स्क्वायर. दिस इज माय डायनामिक प्रेशर फॉर्मूला आल्सो. ठीक है, एज आई टोल्ड यू दिस pressure has what pressure, the formula is half rho v square and its unit is Newton per meter. Okay. Dynamic pressure is common to all aerodynamic forces and determines the air loads imposed on the airplane when it is moving in the air. As I told you, dynamic pressure तभी होगा जब ऑब्जेक्ट मूव कर रहा होगा. अगर एयरक्राफ्ट रनवे पे खड़ा है तो कोई डायनामिक प्रेशर है नहीं उस पर. इसको रिप्रेजेंट करने के लिए है कैपिटल Q एंड स्मॉल q, whereas static pressure was small p. Okay, I'll be using these p and q, so please remember this. And one of the favorite questions by DGCA, dynamic pressure is also known as impact pressure, क्योंकि ये प्रेशर तभी एग्जर्ट करता है जब किसी चीज पे इम्पैक्ट होगा. Okay, why I am explaining all this pressure? Because when you put together both these pressure, they are known as something called Pitot pressure. You must have heard this Pitot. You see this aircraft's photo, this is a Pitot tube. This is what? It's a Pitot tube. Why the Pitot pressure? Because this is a device which is having a small hole in front. If you see a small hole in front. Now this is the reason I was telling you that static pressure is also present in the front, because Pitot pressure is also known as static plus dynamic. If I include both the pressure together, this is known as Pitot pressure or simply total pressure or stagnation pressure. These three things are the same. तीनों की तीनों चीज सेम है. Pitot pressure सेम है, total pressure भी सेम है और stagnation pressure भी सेम है. तीनों बस अलग नाम है. What is this? This is the accumulation of static and dynamic pressure. When the aircraft is moving, all the pressure, all the air particles will go inside. That will be consisted of total pressure. Okay, this is a section. I have taken this. Okay, I have just उसको मैंने खोल दिया है. द ट्यूब को मैंने खोला तो ये ऐसा दिखेगा अंदर से. इसमें आप देख सकते हो द स्टैग्नेशन प्रेशर इज गोइंग इनसाइड. स्टैग्नेशन प्रेशर इज व्हाट? टोटल प्रेशर, मतलब Pitot pressure या फिर static plus dynamic. So P plus Q is going inside. Now we'll see some other part known as static port. Okay, one is a Pitot tube which I just covered. Okay, here we are getting what? P plus Q. Now as you know, there is a static port also present on the aircraft. I'll show you the photo. Okay, we don't have a photo here. I think it is present on fuselage. Fuselage is the body of the aircraft. Let's explain you what this is. Static port is also present. Now understand this carefully. Pitot tube का जो मुंह है या फिर Pitot tube का जो इनलेट है वो हमेशा एयरफ्लो की डायरेक्शन में होगा. क्यों? क्योंकि हमें डायनेमिक प्रेशर की चाहिए, डायनेमिक प्रेशर चाहिए. अगर हमें डायनेमिक प्रेशर नहीं चाहिए, इफ वी डोंट वांट डायनेमिक प्रेशर, देन व्हाट विल यू डू? वी विल हैव अ स्टैटिक पोर्ट लाइक दिस, सो दैट डायनेमिक प्रेशर ऐसे चला जाए. ठीक है, डायनेमिक प्रेशर यहीं से चला जाएगा. ओनली विल बी लेफ्ट विद व्हाट? स्टैटिक प्रेशर. बिकॉज आपको मैंने बोला स्टैटिक प्रेशर इज प्रेजेंट एवरीवेयर ऑल द टाइम. तो यहाँ से क्या जाएगा? सिर्फ P. यहाँ से जाएगा P प्लस Q. तो ये ऐसा डिजाइन किया गया है, आपको मैं दिखाऊंगा. देयर इज अ कैप्सूल एंड ऑल. ऐसा डिजाइन किया जाता है कि Q कैंसिल्स P कैंसिल्स P. I am left with just my dynamic pressure, that is Q. This is known as ASI. In simple words, airspeed indicator. Okay, because Q क्या है अपना? Q is a pressure. That pressure will move this needle, and that will give us the reading. Okay, any doubts in this?
No, sir.
Yes.
Sir, ASI is not true airspeed, right?
Yes, that is what I'm going to come into. Good, you pointed out. ASI's full form is airspeed indicator, and it gives us indication of a pressure. That is dynamic pressure. Now you must know this fact that this is a pressure. This is not an airspeed. What this guy was telling, this friend of ours telling me that it is dynamic pressure is something different than true airspeed. We'll discuss this. We have a time together right now. Okay.
So is it just the dynamic pressure airspeed indicator?
Yeah, we'll solve your queries. Don't worry. There are a lot of curious people here, I see. So dynamic pressure is the balance of total pressure. I'm just giving you a perspective right now. Today only we'll discuss a lot of many types of airspeeds and pressures. All right. Sure. So this is our ASI. See, static pressure I told you on the fuselage, and this is our pitot tube. यहाँ से आपका P plus Q आया, यहाँ से सिर्फ आपका P आया, and you get your dynamic pressure. Right. So just before we start airspeeds and pressures, कौन से pressures हैं, true airspeed, what is IAS and all, we'll just conclude by giving you an introduction to humidity once more. As I told you, humidity is just like opening this water bottle से water particles निकले, so they occupy the space. When they occupy the space, overall, what happens is, my density reduces. Okay? I'm just adding this because ये line DG से बहुत बार पूछ चुका है. ठीक है? The reason increasing humidity decreases the air density is that the density of water vapor is 5 by 8. Remember this value, 5 by 8 of our dry air. Sure. Okay. Humidity is important. Why? Because अगर आप मुंबई की बात करो, मुंबई is very humid. That is the reason उसकी performance. अभी humidity ज़्यादा है मुंबई में, that means density कम है. मतलब आपकी performance मुंबई में बहुत कम होगी. The performance of an engine or an aircraft will be very, very bad. Okay? So, ये important. This is the reason.